Okay, so before I talk about LANs, I'm going to talk a little bit about WANs. I'm going to go into LANs more in depth and WANs, but that'll be later on in these videos. Uh, WAN is the opposite of LAN. Okay, so what is a LAN? It's a local area network. Well, what characterizes a local area network is a small geographic area. Okay, what makes a WAN or characterizes a WAN is a wide. See, this W here is important. A wide area network, so it's a wide geographic area, such as the city of Houston or whatever city. Okay, basically, basically you have your ISP. Oh, yeah, okay, your ISP here, right? Okay, and then you've got all your individual houses here, right? Okay, let's say this is cable internet. I don't particularly like cable internet, but we'll talk about that later. Um, this is your ISP, okay? And they spent all this money to run these cables to these houses, okay? So these people have cable TV already. Well, most people, I would say, especially in my area, have cable TV. But they spent all this money to run these cables throughout the city. And what they're going to end up doing is using a piece of this cable, or not a piece of it, but bandwidth, a certain frequency on this cable to encode internet information, digital information. And a lot of people have digital cable now, so it kind of works both ways. But basically, you have this is how this works. Okay, you have two types of signals. You have analog and digital. Okay, analog and digital. Okay, your analog signal looks like this. Okay, kind of a sine or cosine wave, whatever. Okay, and generally on these types of signals, you have, well, always on these types of signals, you have your amplitude, which is the height of the wave, and your frequency, which is the length of the wave. Okay, and you're either going to encode your information using the amplitude or the frequency. Okay, so they encode the information by changing one of these two things. Okay, well, with the digital signal, you don't have this sort of nice little wave. You have something that looks like this, more of a block hue type wave. Okay, and in here, your ones and zeros are encoded with using different wavelengths or amplitudes. So it's going to be either one height or a less height. I don't know what the exact height is or frequency, but it's going to be one frequency or another, and those will be your ones and zeros. Here, it's either on, the electricity is on, or it's off. Okay, and in a WAN, generally, well, not so. Mm, yeah, sometimes these days, most technologies, WAN technologies, use this analog. They convert from digital to analog, and that's called modulation. Okay, and they do this. Okay, they encode it from digital to analog. All right, that's modulation, and then when it gets to the ISP, it's traveling over this cable here using this analog signal. Okay, here in the computer, it's a digital signal. So there's got to be some way to, what changes these? Well, when it gets to the ISP, it demodulates. Okay, demodulates the signal back into digital. Okay, because you can't go very far with a digital signal because it starts out nice and strong, right? Okay, but then after a while it gets weak. Okay, and this is called attenuation. So basically you end up with just zeros. Okay, but in an analog signal, it can travel much, much further because the frequencies and amplitudes are, they don't attenuate very much. They'll be the same. The level of, your electricity, like how much voltage or whatever actually reaches, the end of the wire may be different, but your frequency or amplitude will be the same. Okay, so it may be, you may have less voltage as you reach the end, but it'll still be readable. It'll still be able to be demodulated. So what device do we use? And it's called a modem. Okay, modulate, demodulate. That's where this word comes from. Okay, so we connect into our modem here. Okay, here, and then they've got a demodulator over here. Another modem over here. And the signal, modulates, goes to analog, travels along this wire, reaches the end, demodulates back into digital. And that's how we communicate with our ISP. Now, in the consumer market, like the home market, we just use, we take our Ethernet over, plug it into our modem, okay, and it does this for us. We just connect the cable or DSL, whatever, or the phone line into our modem. Well, in the commercial market, excuse me, the really high-end corporations and stuff, they use what's called a serial connection. Okay, serial connection. All right, and this will connect into a fairly high-end router that has a serial connection, but it'll connect into the router, okay, and then it'll go to what's called a CSU, DSU. Okay, and this channel service unit, data service unit. Okay, and there are different types of these. We've got all the T's and E's, like T1, T2, T3, E1, E2, E3, and then the Japan, and the difference between those is we use the T series here in America, and Europe uses the E series, and then Japan uses their own series. But they we all use different technologies, and also you have these for fiber optic lines. So that's another way to encode this data into light, basically into light signals, and it reaches the ISP and gets turned back into electrical signals. Let's see what else. Bandwidth. Let's talk about bandwidth. Hang on, let me clear this out. Don't mind that. Okay, so let's talk about bandwidth a little bit. Alright, bandwidth. You've got, on any given line or wire or whatever, you've got a certain amount of stuff, electrical signal, that can fit inside here. Okay, and how it's separated, well, especially with cable and DSL, is by frequency. Okay, so in a telephone line, you've got this much being used, okay, this much here being used for your analog voice, okay, and then you've got all this left over here, all of this left over for whatever they want to use it for. Well, they came along and said, well, let's use it for digital data. All right, so they used this whole thing here, and this is only about, I think it's 64 or 72, okay, kilobits per second. Okay, well, that's not how you spell that. Kilobits per second. All right, so this is kilobits per second. What's a bit? A bit is, well, it's 8. Okay, a byte is actually 8 bits. A bit is a 1 or a 0. Okay, that's only, you have 8. Okay, so you have 8 bits in a byte, right? All right, so this byte is how we measure storage. Like you've got a gigabyte of storage space on your hard drive. Well, these, your internet bandwidth is measured in bits per second. So it's either, and it goes by the SI units, like, bits and then kilobits, megabits, and so on. And so bits per second. So this is about 64K kilobits per second. Okay, and you've got all of this left over. I don't remember exactly how much it is, but it's quite a bit actually. So, and they use this to encode your digital data. And it's not digital whenever it's on the line, it's analog, but you get the point. So we've got all this, we use all this, and this started out just using, whatever was left over here. So like, n minus 64k, okay, or 72 or whatever. I don't remember exactly what it is, but they use, this to send internet traffic. So n equals the total number of bandwidth. Okay, so n minus 64k. They use this. Okay, well, they figured out different compression methods, and we've came up with new methods of DSL, like ADSL, okay, SDSL. And we'll discuss all this later. HS, DSL. Okay, and DSL stands for just direct subscriber line. Okay, and you've got asynchronous, which means that your download is much higher, is much larger. Your download speed has more bandwidth than your upload speed. Okay, and synchronous DSL, they are exactly the same. Okay, so but it's not as much. Like basically take the difference between these two. Okay, and that's what these will be. Okay, you take half of the total, and half of it will be used for up, and half of it will be used for down. In high-speed DSL, high-speed synchronous DSL, okay, you've got a lot of bandwidth, up and down. Okay, and I think there is a high-speed asynchronous DSL as well. But these are the different methods of DSL, and they came up with these, and generally right now we get about 6 megabits per second. Okay, and that's megabits per second. So whenever you're downloading something, you don't see it in bits per second. You see it in bytes per second. So you won't see this 6 mega. You'll see something like 512K or 600K. All right. Actually, maybe in whenever you download. I don't know. I'll have to look at that. But you won't see as the whole bandwidth because you've got a lot of overhead, and we'll talk about overhead here in the next LAN video. So that pretty much covers it for. And cable works the same way. They use some of this for your TV channels, and they use the rest for your internet service, and so on and so forth. So that's bandwidth. And that's pretty much all I have to cover for right now on WANs. And we'll get into more detail in a later video.